Astroscale is about to attempt to deorbit an uncooperative old rocket body in space, demonstrating technology that is absolutely going to be needed and crucial for the future of humanity's activity in space. They are testing technologies and sent us this time-lapse footage of orbits around this rocket body. Look at this, it's gorgeous. This is not a render, this is not science fiction. These are actual images that they took while orbiting this rocket body. So I'm talking about the Address J mission, that is the active debris removal by Astroscale/Japan. Astroscale is a Japanese company that has several subsidiaries. So Astroscale Japan, Astroscale in UK, Astroscale in US. I'm the executive director of space consulting firm Astrolitical, and recently when we were doing work for a client, I realized just how dominant Astroscale is in winning grants around the world to do this kind of active debris removal. Now, Astroscale Japan actually got 2 awards from the Japanese Space Agency JAXA to do first this mission to examine this rocket body, and second to deorbit it. And I'll go into all of that. I'll go into the timeline of all of this. But first I want to say this time lapse that we saw, these pictures were released today, but they were taken 2 weeks ago on July 15th. And these are not the first images that Astroscale has sent us from this rocket body. They actually started taking pictures back in June. What we're looking at here is a 15-year-old upper rocket stage from an H-2A rocket that launched in 2009 satellite, the GOSAT. This is the piece of space debris, space trash that has been targeted by Astroscale. But before they go ahead and try to capture it, which it was never meant to be captured, but before they go ahead and try, they are orbiting it to make sure that they can observe every bit of it to see that it is safe to approach it and to attach to it. So for example, we know that there are pieces of satellites and rocket bodies up in space right now that are tearing off pieces of itself, outgassing, and other types of hazards. And that's not this body. They just want to make sure that this rocket body is safe to approach and capture. And what they wanted to do was they wanted to capture the images at different angles and different lighting conditions. So it's not like the movies where you just kind of circle it, like no problem. It's not like science fiction at all. It is really complex. So while this rocket body is orbiting Earth, Astroscale is orbiting it, and the lighting conditions are changing, the angle with which the orbits are happening are changing, and there's probably some kind of rotation going on with the rocket body that is also changing. So what they're trying to do is maintain a fixed point as they orbit this rocket body from approximately 50 meters away. So backing up a little bit, the start of the mission actually began back in February. February 18th, Address J, that's the mission, it launched on Rocket Lab and started its in-orbit operations. Then once they were in space, they needed to rendezvous. So February 22nd, they began to start rendezvous operations. There's a whole lot of milestones here, so I'm just going to go ahead and read them. April 9th was the start of the angles-only navigation and proximity approach from several hundred kilometers. April 16th was the start of the model matching navigation. April 17th was the approach of the client within several hundred meters. And then May 23rd was the approach to the client. The client is the rocket body, by the way. Approach to the client within 50 meters, and that was their target, was to get 50 meters from the rocket stage. May 23rd was also when the first fixed point observation was completed. And then June 17th was the second fixed point observation that was completed. June 19th was the start of the fly around operation. And in fact, they put out a press release. I'm linking all the press releases below, by the way. They put out a press release saying that they had run into difficulties and actually had to abort their first attempt to go around this rocket body. What they did was they went and approached this rocket body up to 50 meters, and then they started to observe it using LiDAR. You might be more familiar with LiDAR when it comes to Earth observation, but in this case, they used LiDAR to probe this rocket body. They went about a third of the way around, about 120 degrees, before they got an alert that it was unsafe. An autonomous abort was triggered by the onboard collision avoidance system due to an unexpected altitude anomaly, and Address J was safely maneuvered away from the client as designed. So they had to abort that attempt, but then they went back in July and tried again. July 14th was the approach to the client within 50 meters, and the third fixed point observation was completed. And then July 15th, which is when those time-lapse images were taken, that was the successful second fly-around observation, and then July 16th was the second successful third fly-around observation. So they went around full time twice. But of course, they didn't go all that way just to fly around this rocket body. The first contract that they got from JAXA was to test this rendezvous and observation technology. The second phase of the mission, which they won an award earlier this year from JAXA, is to actually capture this rocket body and bring it back down to Earth. And by that, I mean burn it up into Earth's atmosphere, and anything that remains goes into the Pacific Ocean most likely, although they haven't really given us those details yet. Now, this is an unprepared rocket body. It was never intended to be captured. It was never intended to have anything latch onto it other than the rest of the rocket, of course. It is 11 meters long, 4 meters in diameter, and weighs about 3 tons. They say it's about the size of a city bus, if you want to imagine that. And what they're going to do is they're going to capture it at the payload attached filing. So wherever the payload was, the GOSAT, that is where they're going to attempt to attach on to this satellite with their satellite and then deorbit it. We don't have any kind of timeline as to when they're going to do that. We're going to find out probably when they put out another press release saying that they've done it. And I wish them the best of luck because, as I said at the start, this is absolutely crucial technology for the future of space operations for all of us. I've put out several videos on the topic of needing to clean up our orbital debris mess and being good stewards of our orbital environment. Most recently, I want to point you to a video that I did about whether or not we should be deorbiting this kind of material in space, or maybe we should be capturing it for recycling, as a longer term goal, not in the near term, obviously. And I do think it's super important that we get rid of the trash in space in any way we can. But those rocket bodies contain really valuable materials that hopefully we can recycle in the future. And I did have a client at one point who is working on recycling of that metal in space. And there's all kinds of technical complications and legal complications to all of that. But if you're interested, watch this video after this one. The European Space Agency, ESA, put out a report recently called the Annual Space Environment Report. I will link it down below, in which they talk about some of these things. For example, 35,000 objects in orbit are at least 10 centimeters across, which is about what they can track. So there's a lot of pieces of space debris up there that is just untrackable with current technology, but about 10 centimeters across is the threshold. So anything 10 centimeters and above is generally what we, by we meaning different entities around the world, can track. Another source I found said that there are over 2,200 spent rocket bodies in space. I don't know if I trust that number, so if you know of another source, go ahead and send it in the comments, because I would actually love to have really good, accurate information about this. Like maybe Jonathan McDowell cracks this, or Leo Labs or somebody, so let me know. It's a huge problem when we think about the fact that there are only certain orbits that we actually use, and they're getting more crowded, and they're getting more crowded with things that are no longer active. We have accidental breakup of these objects, like the Russian satellite that recently broke up and created a bunch of pieces of space debris, thankfully in a lower Earth orbit, so they burnt up pretty quickly. And then we have purposeful blowing up of our own satellites with anti-satellite kinetic testing. So no matter how you look at it, there's a lot of space trash up there, and if we keep on being irresponsible with what we do with spent rocket bodies and dead satellites and all the other space debris that we have up there, the orbital environment around Earth is not going to be safe for us to use. The number of conjunction warnings are increasing. That's the number of times satellites, active satellites, are being alerted that there is something coming too close to it and they need to maneuver away from it. And this is especially dangerous when we're talking about space stations, both ISS and Tiangong space station and any future commercial space stations that have people on board, because the space stations also need to maneuver, and usually, at least with the ISS and I think with Tiangong space station, the astronauts actually need to shelter in place to ensure that they are safe from space debris that might hit the space station that they are on. And space debris could be these little specks, or it could be these large rocket bodies size of a city bus. And there are debates as to whether or not we should target space debris that is large, like the spent rocket bodies, like the dead satellites, or maybe we should go after these smaller little pieces. And I am more of a yes and person than an either or person. I think we should target both, because both of them cause problems and both of them require similar but different technologies to solve. I am rooting for Astroscale. I am rooting for ClearSpace. I am rooting for all of these companies out there that are trying to develop this technology to clean up the mess that we have created over decades decades of irresponsible space use. And even if we get to be more responsible with what we do with spent rocket bodies, like for example, landing them back to Earth like SpaceX does, or the dead satellites, for example, the new FCC rule here in the United States of deorbiting within 5 years after the lifetime of the satellite, and all these other rules that we're starting to put in place, this zero debris charter that ESA has started. All of these are great, but no matter what, we're going to need this technology because accidents always happen, as we saw with the recent Ariane 6 launch that had an anomaly that left the second stage rocket body up in space. So maybe some years down the line, Astroscale or some other company will go and attach to that Ariane 6 rocket body that's still up there and deorbit it. I don't know, but that is hopefully where we're going with this technology. And not only with spent rocket bodies and smaller satellites, but also giant satellites like the International Space Station. So go ahead and watch this video next if you're curious how SpaceX and NASA are teaming up to safely deorbit the ISS.